Okay, Java keywords. So this table on the current slide, it actually lists out all the keywords which we have in Java out there. Okay, so if you have a look at, it's got a total of 49 keywords, and this is as per the JDK 1.4.2 version. So I think the latest version has got probably one or two keywords added to this list. Okay, so what is a keyword in Java? So a keyword is nothing but it's a word which has got some kind of special significance to the Java compiler, right? So whenever the compiler comes across any of these words in the Java program, it knows that it has to deal with it in a special way, right? It's not just a simple word. So basically you cannot use any of these keywords in your program in any other way, right? And only in the way in which it's actually supposed to be used, right? And each of these keywords given out here, each one of them has got some kind of significance in the Java programming language. Okay, so we've actually seen some of the keywords already in our earlier examples, right? Like we've seen what a class is, we've seen new, we've talked about package, we've talked about public. So some of the keywords we've actually already discussed, and we know how to use it and where to use it and why to use it, right? And in the future slides till the end of by the time we complete this uh, whole tutorial, we will actually be using and talking about all the keywords which are out there. So by the end of the session, you will actually know what each keyword is, what's the significance of each of the keyword out there, and where to use it, and how do you use it, why do you use it, right? Okay, we've discussed quite a bit about the classes and objects and instances in our previous slide. So here we are actually going to take a closer look at that, and we are going to see how your data is managed in the Java world. So here we will also be discussing about the difference between stack and heap. So what is a stack and what is a heap? They are nothing but data structures in Java. So whatever data is stored in Java, it either resides on the stack or on the heap. So we will now discuss here what resides on the stack and what resides on the heap. Okay. So let's start off with a simple example. Let's say you've got a class in which you've got a main method. The main method calls method 1 and the method 1 calls method 2. Now let's say that method 2 has got some local variables that is declared within the method. So say I've got an integer x whose value is 10, and also I have a reference variable y which actually refers to the instance A. Okay. So if you see here, this local variables are being defined in the stack, right? So all your local method variables will reside on the stack. Okay, so what resides on the heap? On the heap, all your instance variables and whatever objects you create resides on the heap. So one rule of thumb you can say is that whenever you use the keyword new, you are bound to create a new object on the heap, right? So when I say the object is stored on the heap, what exactly is stored on the heap? As you see, the stack stores the local variables. So similarly, the heap will actually store the instance variables of the class. Now say for example, A has got 3 instance variables, that is x, y and z. Okay, so the values of x, y and z is what is going to be stored on the heap. Okay, so that is nothing but it defines the state of the instance or state of the object. So let's say x is 1, y is 2 and z is 3. So these values are actually being stored on the heap. Okay, so that's it. The heap actually stores your objects and instance variables, whereas your stack stores all your local variables. Okay, the stack also stores the execution state of the methods. Now we know that method 2 is called, and method 2 has got some operations and some statements out there, right, which it has to execute. So once all the methods from method 2 are executed, it actually pops out the method 2 out of the stack. So stack is, as the name suggests, it's nothing but last in first out data structure, right? So whatever comes in last goes out first. So once method 2 completes its execution, it simply pops out method 2 out of the stack, and it also clears off all these local variables. It's no more accessible since method 2 is out of the stack now. And similarly, in the end, after popping out everything, the main method is also popped out of the stack, and the stack is now clear again, ready to be used, right? So in this manner, the memory is actually allocated and deallocated when it comes to a stack. And how is memory managed in a heap? Creation of objects is up to you, right? You just say new, and a new object is created on the heap. But how do you deallocate the memory? That is up to the garbage collector. It's not up to you. So that is completely a different topic which we will be discussing later in the session. Right. So I hope the difference between stack and heap, and when to use stack, not when to use, basically what is stored on stack and what is stored on heap, is a bit clear to you. So we now know that Java is an object-oriented programming language, right? And it complies to all the object-oriented programming concepts. So let's see what those concepts are. What are the object-oriented concepts all about? So this slide actually lists out some of the basic OOPS concepts which we have. Right? The first two things, class and object. This is something which we've been discussing about a lot till now. So I won't put a lot of focus on these two things. You already know what a class is and what an object is, right? Coming to abstraction. What is abstraction? Abstraction is nothing but hiding certain details and show only the essential details. Okay. So basically, when you have a look in the future slides, when we talk about modifiers and we see how you apply the abstract modifier to the classes and methods, you will actually see what it really means and how you actually employ this abstraction feature. So say for in a class, say implementing everything doesn't really make really sense to you, right? If in a particular class, you can just hide certain details and only the essential details you can implement, right? So that's nothing but abstraction. Encapsulation is binding data and methods together. So basically, the end product of encapsulation would be data hiding. So as you implement the encapsulation, you actually end up employing the data hiding functionality. So say for example, you have an employee class in which you have the salary as an instance variable, okay, and you've got a set salary method. So and I don't want anybody to come in and set the salary for an employee, right? I don't want anybody to have access to that, to be able to set a salary to any person out there. So there I will make use of encapsulation to secure that thing, so that nobody will be able to make changes to my salary, and only certain authorized people can make changes to the salary. Okay, that's encapsulation all about. Inheriting the features of a superclass. Right? So let's say that car is a class, okay, and say for example Nissan is a type of car, right? So it is actually a subclass of car. So Nissan is now actually going to inherit certain features of the car. So we all know that in general a car has got, like, it's got 4 tires, it's got a steering wheel, it's got seats, like things like that. So all these features a Nissan basically implements from a car, right? So it actually inherits these features from a car. So that's what inheritance about. You can inherit the features of a superclass. And polymorphism, having one name with many forms, right? So let's take an example of a class called shape. Okay, so it actually, a shape is nothing but it can be of any shape, right? And there are actually different classes which subclass out of the shape class. So there could be a triangle, it could be a circle, it could be a rectangle, or one of the many other shapes which we have, right? And say we have got a method called area. Okay, so now in each of these classes, the implementation of the method area is completely different, right? Because if you want the area of a square, you just say side into side, and if you want the area of a rectangle, you say length into breadth, right? So implementation of that particular method area is different in each of these classes. So that's what polymorphism talks about, having one name with many forms, right? So I hope it's at least a bit clear now, like what are the different object-oriented concepts and what they are. But we will definitely be reviewing these object-oriented concepts in the future slides, and we will actually see examples of each of these concepts in the future slides of this tutorial. Alright, okay, now data types. So what is a data type? So data type is nothing but you assign a type to a given literal in your Java program. So you can have different numbers in Java program, right? You can have 10, 11, 12. Say for example, in a student table or in a student class, a roll number, right? It represents a number generally. So roll number 1. So if there are 10 students in the class, you will have roll number 1, 2, 3, 4, 5, 6 up to 10, right? And it's stored as a number. And the next thing you have in a student table is the name, student name, right? And it's not a number anymore now, it's a string, right? A set of characters. And say for example, one more thing you have in the student table is gender, say for example, and it is either M or F. So M stands for male and F stands for female. So that's a single character, right? So you've got these different types of data which you would like to store in your class, right? And all these types are not the same, they're different, right? So in the similar manner, you've got different data types in Java which can store these different types of data to you in your program. So we've got all these list of data types which are listed out here, and I've also listed the number of bytes it stores, and the minimum value, maximum value, and the literal values which it can accept. So if you say for example look at the byte data type, it's got only, it stores 1 byte, right? That means 8 bits. So the number of bytes, as the number of bytes increases, the amount of data you can store is will also increase, right? Obviously. So the larger the data, the bigger the data type you would require. But most of the time, if you are dealing with numbers in Java, you use integer data type. Okay. And if you've got a very long number, you use long. And when you have decimals, you use float most of the time. Okay. So the general rule to the min value and max value is this: min value is to the power of bits minus 1, number of bits minus 1, and max value is to the power of number of bits minus 1 minus 1, right? But there are certain exceptions definitely to this general rule. So say for example, a char data type is an exception. It really doesn't have negative values, okay? And the maximum value is to the power of 16 minus 1. So basically the number of bits would be 16, right? So it's to the power of n minus 1, to the power of number of bits minus 1. And float and double basically doesn't have any min value, max value. Same case with boolean, it's got only 2 values, either a true or false. So this is about the data types. Actually, when we implement all these different data types in the demo session and see how we can actually convert one data type to another, and how actually some of the data types actually implicitly converts to other data types. So when we do the demo, things will be more clearer, right?